Hello, Cardstack community. This is Chris C., the founding director of the Cardstack project. Today, I want to give you an update on the work that we're doing on the schema part of the card. So card schema is how you define what a card is, what is relationship with other cards, and using that definition, create this composable user experience as well as data system that allows card to move around. And we've been using card schema as the basic building block for a long time. So we have built many applications, and we've recently released a lot more documentation about how people can leverage schema and define relationship to build applications that are composable, not just in a single application point of view, but also leveraging components from other applications to build up your application from parts. And the traditional card schema, let's call it card schema 1.0, focuses on dividing the problem of defining what a card is, its fields, its relationship, from actually encoding the data using that. So it's similar to defining the column of what you're putting in a spreadsheet, and then putting the values in in the rows underneath. So that's always been kind of a separate concept. But if you want to then create a thing that can move around, you want to combine that together. Now, Excel is very good at this. When you open an Excel file, it contains the definition, the columns, and maybe the formula, which we call computed properties, as well as the instant data, which is what's underneath it, and the things you type in. But when you talk about databases, especially databases on the web or something like that, it's very hard to say, I want to take my data from Google and then move it to Facebook. What does that even really mean, right? And that's equally true from I want to take my data from Salesforce.com and move it to MailChimp. You need very specific adapters to bring it together. But what if the actual information you enter about your customer, about yourself, is actually combined as this thing called card that includes both what it is and self-describingly what the data is? Then we can facilitate movement across hub around system. And that's what I want to talk to you guys a little about. This will be a fairly technical talk. This was actually initially prepared for an internal audience for us to really understand kind of from an engineering point of view some of the hard problem we need to solve, and it actually led to a lot more of the design that we'll share soon in documentations and sample schema document. But right now, I want to catch a community up on kind of what we're thinking around that. So let's start from kind of the basics of what is a card. This is a question I get asked a lot, especially since Cardstack is a company and an organization and a foundation. We typically use card for everything. Everything is a card. But from a framework and from a programming and a design point of view, a card is an application at a state. So a card is both the app as well as what you put into the app. So that's quite unique. When you're talking about an application that does a to-do list, you think of your to-do list as the app, and then your entry, what you type in your checklist, that to be the state or the data. But a card contains both the information. It's almost like you write a Word document, and then you put a little check mark next to it, and you type your thing. The Word document is kind of like also the app, and then the state is that. And a web page is actually a really good place to do that, because a web page, when you open up Twitter or something, is actually loading the app of Twitter app and then looking at your account and seeing what state, what information about your Twitter account fits into that app, and then render your tweets. So a card is also one more thing that it has an identity, it has a URL, it has a link that exists. The goal of making a card at a state that has an identity, so combining services, the storage, and the kind of references, is that the end user actually perceives the card to be a physical thing. It's almost a screenshot that you can move around. And when they actually edit the application or schema, they can now edit it within the thing. The same way, if you have an Excel file and you want to say, hey, I want to have a slightly different formula to predict my revenue or my profitability target, you can go to the app and then change the formula. That's changing the code. Or you can say, let me punch in some information about my sales in July, and then that updates the thing. So card is like a document, similar to what we saw in the Office document era, and Excel being the best example of that, where it's self-contained, it had both the template and the schema included in that. And the idea here is that the environment, which is the Cardstack environment, the app you build around cards, uses the services and cards. Say, hey, you told me you have an estimate of your revenue or your projection for this quarter, what is it? And Excel can kind of do that. You can link two Excel sheets together and say, take the output of sheet 3 and use it as an input of this field. But the composability sort of breaks down a little bit once you have a couple more sheet library in the thing, and then you upload it to the server, and then suddenly all your links break. But on the web, that's much more reliable. I can know that I can always get the latest information from my bank because I have an API. So card has this idea that every card is also an API, and that's why Cardstack implements our card in a server using Node.js in something called Hub. And that Hub, based on your definition of a card, generates an API that's the same APIs that you get from a Gmail, a MailChimp, or Intercom, or whatever it might be. So the services is part of that. So that's what a card is. The environment interacting with card through services, has its own storage, and has a link. But if you just go one level deeper and say what's in a card, so a card includes these 3 components, and those 3 components include, for example, in the service, the application. An application, any app, iPhone app, web app, has the data, which is a schema. What is the data about this app? Oh, I'm an app about dog walker. So these are the dog walker, these are the locations, these are the cities, and these are the dogs, these are the prices, and those schema make up the application. And the templates would be the map, the booking screen, the checkout screen, the account screen. All these templates exist. And then in the Cardstack universe, we have an isolated embedded template, so card can contain other cards and can be themselves. So an embedded template would be embedding a YouTube video inside a block. YouTube renders that little self-contained video with the play control on the bottom. It also is an isolated view. So when you go to the YouTube link, it has related content and a title and then comments and description. That will be the isolated. Every card is like a YouTube video, except it's not just video, but it could be about to-do lists, it could be about invoices, it could be about payments. All these things exist in the template. So the schema is about data types. So it's like my card is a to-do list, so it has is it done yet, and then the checkout, and maybe have a due date. But if your to-do list end up marking some sort of business process, you may want to attach it and say, oh, this item actually links to whether the credit report has been returned, whether the loan has been approved, whether the car has been returned. So that idea of containing other card and using other schemas is quite powerful. And the storage, which is the second part of this thing, the storage has 2 other things, right? Which is what is actually in the field, what is stored is part of the card, but also reference to other card. For example, I made a song, so this is the name of the song, and I'm going to reference who my collaborators are, and that will be reference to other card, the artist card or the union card if you're putting together a Broadway show. That will be pointing to other cards. And the reason why you can do that is because every card has an identity. So you can say, oh, who played on your thing? Say, oh, let me go to the card, find that card of my friend's union card, copy and paste that, and boom. That's how you link together your new work and your new show or your new song or your new play, and then you kind of link it to another person's. So it's kind of web-like in a way, and it kind of mixes the things that we like about the web, the hyperlinking aspects of it, as well as things that we like about application, which allows you to interact with it and have a consistent user interface. That's what's inside a card. Once you have a card, then you can say this card is in my library. It's almost like saving a file to your personal folder. But you can also, same way, and say, you know what, I'm going to take this card or this set of template, schema, fields, relationships, and link and put it in the catalog. And that's where the world of managing your own files on your computer and interacting with websites and web application and web platforms become a little bit different. Because usually what you have on your computer is not easily become something on the website. You have to upload it, you have to copy and paste in the forms and stuff like that. But with cards, because they're self-contained, it's literally just like, here's my card. And then that card contains everything, and suddenly it shows up on the shared catalog. And that's, we'll get to that in a little second, a little bit more about how that works. But that's the power of this self-encapsulation of the card. So let's take a look at the schema aspect within the card services. So a schema has really 2 components. There's the public face of the card and then the private implementation of the card. One way to think about it is that sometimes you want to have a information that has a lot of detail. An invoice is a good example of that. It's like the invoice, we have some line item detail and it points to certain products I have, or there's some discount or some notes and some special notes to accounting and stuff like that. That will be the private fields. The public fields, like, hey, since this is an invoice, it should give me a due date, has it been paid, what's the value of it, what's the tax, maybe some currency information. Basic standard interoperability, so that if I receive invoice from 10 different organizations, looking at the metadata, they're going to look kind of the same and conform. And even though I may not know exactly what the invoice implementation detail, the private information, I can still act on that publicly available data very similarly. This is actually very much what happens on the web, right? When you put something on the web, you have a lot of fields and a lot of template to create this web page. It could be a boarding pass, it could be a flight information, it could be a product on an e-commerce store. But you have some public data that you mark up, and then Google and search engine and stuff like that looks at those public field. Facebook look at the public field of your blog post and then extract out the thumbnail image, the title and description of the author, and give you a nice little teaser on the newsfeed. And that's the metadata. So it's something that I think that has an enterprise and like backend system tradition, but also through the web, semantic web, or the search engine optimization world, also is meaningful in the web. So that's kind of what happens in the app. The metadata is kind of like the interface that shields some of the low-level detail. And then the way we design this is that because the schema and the services are all part of the API family, you can actually see the metadata and the fields. And if you go to Cardboard, which is a demo we did a couple months ago, you can see that an article has all these fields. And we're now working on making some of those field metadata so you can actually syndicate it to Google News or something like that. So that's what a schema is. It contains this public and private situation. Now, what happens when you're composing a card, when you say a card contains another card, is that you do something called delegated rendering. The easiest example is always, I have a blog post that has a YouTube video. So your blog post contains a link to a YouTube video, right, that you pasted in, and it embeds the template from YouTube, in this case, an embedded template, the YouTube player, that where you say, I have this blog post, I want to render myself, my title, my information, but when it comes to this video, I would like to delegate the rendering to YouTube and have them compose that together. That's called iframe. So ads do the same way. I have a website, I want to make money, I'm going to delegate the rendering of this portion, top banner on my site to this ad network or this ad agent, and they're going to render that. So the first version of Cardstack was actually based on iframe, based on this technology. But one of the problems with that is that it's extremely inefficient to constantly doing iframe. And that's one of the reasons why a lot of ad-supported websites and publication sites are so slow, is because they have all these iframes and all these JavaScript that's running within and outside and between the iframe, doing all these things. When you go to an app, like a nice, well-constructed SaaS app, all the templates and all the cards and all the components are actually part of one app. They might load and get delegated in a certain hierarchy, but at the end of the day, they're actually part of the same code base and therefore doesn't have that weight. So we have been supporting kind of this delegated rendering in the Cardstack framework. In fact, almost all the apps we've shipped so far has embedded template that gets built up. So when you go to a cardfolio or portfolio, each of the crypto assets is actually delegated rendered of that thing. If you go to our Cardboard application, the media assets and the rich text that make up the article is actually delegated rendering. But we want to now introduce a new way, a more standard way of doing this. Sometimes you don't actually need to delegate the rendering and say, hey, please draw your video. A good example is that we attach something into an email. You might just want to know the file name and how big is the file, what type of it, and that's from the metadata. Sometimes the template, the containing card, just needs to list the metadata, or for example, you want to have a expense report and you drag some receipt into it. The receipt all has metadata about when and how and what type category. You want to be able to then say, this is how I sum up all the thing. Here's a table. These are all the metadata that is conformed from each one of those things, and that's how I render this list. So in Cardstack, we have this either or between using delegated rendering to build up your application, or as the containing application, as the invoice, the expense report looking at receipt, you can actually extract the metadata and lay it out however you want, in a grid, in a table, whatever makes sense within your user experience in the containing app. So when we talk about cards are very flexible. They can do anything, right? Because they're just essentially a pile of code with some data in it, and it exposes metadata and has a template that you can render. But as we think about interoperability, we start looking at the ability for you to get something you expect from a card. So we talked about invoices and expense report and receipts and stuff like that. So in this particular example, we're saying, what if a card is describing an event of a conference or a show or a performance from a famous rock band. That event can have certain fields that are expected, such as the door time. It's going to start at 7 p.m. It's going to be 2 hours. It's auditorium. There's a date involved in it. Now, if you're an artist and you want to list all your events, and so events may be in different places, now you can have different stylized posters on the web about each of the event, but they all actually, if you click on them, they're all different, but they can all be listed very coherently within your page template by leveraging this metadata service. And one way to do it to make sure it works all the time is for a card to declare a facade and say, hey, I'm an event card. I know what Google and I know what maybe Facebook or Eventbrite expects of a card. These are common fields that exist in every event. So let me go and comply to this idea and make metadata that actually is always consistent and is part of a standard, so that this can have interoperability. So the first card in the Cardstack ecosystem that ever says I'm an event essentially becomes the template for all the other cards. Hey, that's a good idea, event card, I'm going to also be that. And that's kind of what happens next, right? Which is that if you share your event card, which is a little, have a date and something like that to the catalog, and other people go to the catalog in the Cardstack catalog and say, wow, that's really great. I want to make my event card, which has different layout, maybe have different fields, maybe this is for a sporting event and it's not general admission and has like more information about sections and whatever it might be. You can just create a new composite card that can combine other fields, additional fields like sections and stuff like that, or segments and stuff like that, and then use that facade of the event card and say, hey, I'm going to map my field so that I look exactly like the event card that's in the catalog. So that's what we call field mapping. And when you save this event card can be dragged or added exactly the same way to my upcoming event because it looks like an event card from the outside. That's what we call re-implementation. That's the hard way of doing it, which is that you just kind of map all the fields so that on the outside you look exactly like an event card. On the inside you could be doing anything or calculating. For example, if you have a playlist and you have different shows, some have more songs, you calculate how long your show would be based on what songs you're playing. So you can compute like in Excel, like take the duration, add it up, and that's how long my show is going to be. You can do that even though the original event card in the catalog doesn't support it. You can add the support for the additional field and then map it as duration and as a calculator field. And that allows us to innovate and derive from works that people have done. So a developer starting to build an event system can look at a card catalog, not just as a thing for them to go and make a card and use it on the website, but also as a template or as a starting point of their creation of their own thing. Now, we're also working on something called Adopt, which is a simpler version of this, which is that, yeah, that event card's good, but I want to have a new style and template. I want my font to be kind of gothy and kind of dark because it's a heavy metal show. You can just take the event card, take all its fields, basically not re-implement, just use all the data, and then just change the template, which is not on here, but you can just change the service in the template and then make it look very different using web development technique like HTML, CSS, and JavaScript, and still be able to use all the fields in the metadata. So Adopt would be, I'm using this card wholesale, just changing the look and feel or theming it. That would be great for web developer to come to the Cardstack ecosystem to do some billable work or do creative work for themselves without having to deal with front-end engineering and JavaScript and mapping and stuff like that. But if you're a developer and you want to make your card compatible with other things, then you can use this re-implementation. We'll talk a little bit more about what that will look like. So if you want to have a card that has multiple facades, let's say you create a card that is ticket, it's a ticket, and a ticket is an event, right? If you create a Manhattan JS ticket, which is a meetup we have here locally in Manhattan, you can create an event which has the same exact field as any other event, but a ticket is not really an event because ticket also has a payment The payment for Manhattan JS is for charity, which is really great. And so we want everybody to have paid using by Visa, and then you want to give them receipt. Maybe it's charitable donation, maybe it isn't, but at least it's good to know they haven't received. So there's a receipt in the card catalog, there's an event in the card catalog, we've got different payment forms in the card catalog, and you're just making a ticket. And then when you create the ticket, it is simultaneously a ticket card, a receipt card, and an event card. So if you drag it into an event calendar, it shows up. If you want to drag it into expense report system, let's say your company lets you expense meetup ticket fees, which I certainly hope they let you reimburse conference fee. You can drag that receipt into the expense report system. It will recognize the value and how much you paid, and then that will get added up. So that's really nice, right? So a card, even though to the user it's just a ticket, it is actually serving a purpose of a ticket. So you can scan a QR code at the door, an event, so it shows in the calendar, a payment, so you can show that you have paid, and then a receipt, so you can get reimbursed for it. And then based on what you think your card is more like, it's more like a ticket, kind of like a receipt, less like an event. That actually helps the sim decide when you drag a card into something that expect multiple type, which one you prefer. And this is very much of the inspiration that we have in designing Cardstack, where when you copy and paste something in Excel and you paste it into Word, it's like, I know what you're doing. You're pasting a spreadsheet, so I'm going to preserve the formula. If I paste it in an email, maybe it's an image. If I paste it in a notepad, it just takes a list of names and put it in text. So this idea of being able to use this facade as I was saying, what are you, and can I use the maximal value of what you provide within the card so that we can reduce the amount of degradation as you move a card, copy a card, or paste a card from one system to another as you compose your card-based experience. This idea of weighted facade is actually really important. Now, to do multiple facade, you're going to have to be a developer to understand how to map the fields and what fields it requires, run tests to make sure your fields are actually implemented correctly with the right data type. We're making tools very easy for that, for using the Cardstack framework and the testing facilities. Most users would just say, oh, great, there's a ticket. Let me go and modify the ticket and call it Brooklyn JS or Queens JS or Staten Island, New Jersey JS. And that template becomes something that people can just change the data and make meetup tickets that does the same thing and have all these great capability for their own events. But the developer building this for the first time will have to go and wire this up together and create multiple facades. So tickets and stuff like that are stored in your personal library, much like old files if you have created, or old decks, or old PowerPoints, or old whatever, even old code they created. It may go out of date. It may have it may require a new version of Photoshop, or the old version that is no longer on the market. And that's something. Version control is a really a big problem. And then if you try to upload something to a web service that's based on the old version, a file format that's not supported, it may say, hey, that's not supported anymore, can you update it? But since in Cardstack we have our card catalog, which is also built as a Cardstack registry. I have a separate talk about how Cardstack can be used for building like media registry and stuff like that, but we can also build software registries on them, like an app store, like a card catalog, which is our version of it. We can go and look and say, hey, since you adopted the event card V1 like 2 years ago, let me see if event card author, the person who wrote event card, has a translator. Maybe they upgraded version 2, and then in version 2, they're including a mapping rule that if you ever encounter a card that has the facade of event card 1.0, you're in luck. In the catalog, there is code published by an author that is making event card, and therefore they're like maintaining a software library. They're creating shared infrastructure. They're like an open source maintainer. They want to make sure that all the people who have used the event card as maybe SS or adopting it as using it as the metadata field has the ability to leverage those mapping rules. And that's how you allow a new card that's expecting this new format to be able to get translated. The old ticket card from 2 years ago will continue to work as long as it's mapping into these well-maintained cards. And so in the talk I gave around card makers, we want to make sure that these kind of common cards that people derive from are maintained, and it's something that we encourage the open source developer, especially front-end developer with skills and understand JavaScript, to go ahead and make these different type of cards and create the basic interoperating infrastructure, but also much like a well-maintained open source project, build migration tools so that when people have old card that is using the old version, there's an easy way to use the catalog, use the shared catalog to translate it. Migration is also very important for those that have done database work, especially MongoDB and NoSQL work. What Cardstack is doing in storing the serialization of data within the card is very similar to how document databases do things. In document databases, instead of splitting your invoice into 3 tables, invoice detail, payee, payment, you put them all in one JSON document and store it as is. And what happens is that if you add a field, you have to migrate the data. So the migration script had to exist. Now, because Cardstack or cards are compositional, you can migrate the part that is related to the event separately, the part that's migrated in ticket, assuming you're adopting in a certain way. Now, if you're deriving it and re-implement it, then you have to take responsibility for upgrading a certain version. But there are certain nice things about leveraging this migration, so it shows up in searches. So if you have a new field that gets calculated duration, let's say it wasn't in the event card and it was just a calculation between start time and end time, and now duration between one field, for those that does not have the duration field, you can go and calculate that and use that as a migration script. So that's how new versions get handled. And the version of the card is important, but the version of the data is also as important. So one of the things that about applications is that we have lived through the world where you go to a website, a brand new one, you get on Product Hunt, you find it, full word of mouth, you're starting using the to-do list application, it's great, and you're putting all your data, your state, inside that database, and you're using the template, the UI that they provide, and creating it. And one day they go out of business or they get bought by Facebook and it's gone. All the data's gone. And sometimes you would send a link and say, hey, by the way, here's my to-do list, or here's my membership information, or this is my little write-up. And you share that link, and that link doesn't work anymore because it's broken. So one of the things we wanted to make sure we can do is to make cards much more resilient to these kind of version-related, in some cases, a version is only available on a website or on a hosted thing, and that host is not available anymore. So we do something called snapshots. Snapshot is not entirely different than you going to take a screenshot of a flight or boarding pass in case that it disappeared from the app or somehow the flight got canceled. You don't know, you can't prove that you have a boarding pass. So you kind of just for your own sake make a copy storing the information that you can see, usually in the screenshot or PDF or something like that, and say, hey, this is my particular thing. But that is something we think that the card infrastructure and the idea of app plus state and the link being one thing, we can certainly make a copy of the state. So let's say in this example, you're making a ticket card, but your ticket card actually goes through an API to access the Google Calendar API. So this Google Calendar API tells you it's the 26th. And then you update the UI, but while doing that, you store a copy of it within the card. So, hey, by the way, card, in case you forget, here is the value of what is the thing that I saw from Google Calendar, because it gave me this response that the event is at 7 p.m. on the 26th. So let me write that down. Same thing with payment. You might be using a Stripe API, and when it's been paid, you might take all the data and then write it in the card. So in the future, if somehow this link got severed, you can say, like a good mobile app, internet not available. This is the last known information that I saved for you. Let me render this for you. And that's essentially what snapshots are good for. It's good for resiliency. But it's actually more interesting. It's not just about not available, like being, maybe your Google Calendar authorization is gone. It's for sharing. If I'm sharing data with you, right? Hey, this is a ticket. I'm going to sell this ticket to you. If I'm depending on me having access to the Google API or my Google account, that's not guaranteed. The other person may not have access to the underlying official API data from Google. Even though there's an API that you can access to, but the other person, then when they receive the ticket, would not have it anymore. So this idea of being able to exchange card as if they were actual documents and actual screenshots or printed documents or something like that requires us to save that information in a way that allows it to be a mobility. So any single time that when something goes from a library to catalog, you capture this information. Now, if the other person is saying, hey, I'm trying to make a new event card, they support Google Calendar, it's great, so I can have it update bidirectionally on my calendar. They have to reestablish a link, and then now this will be a new event in October, and that linkage is actually quite useful for the other person using this ticket card as a template for their own workflow. But for this particular example, publisher catalog, It's just some static data. What was live data was static. Now, if you're looking at it yourself and you have it on your computer and you want to say, I want to see what the live data, has it been updated? Has the date been changed? Has someone canceled an event? Or has my credit card get charged or charged back? You want to be able to switch between the snapshots and live data if you somehow privilege to see the sources. But if you don't, it's good for that to be there. So this over-the-wire response, so what has been sent back from the payment card, is entirely within the card and therefore entirely within the Cardstack environment. So it's quite easy for us to just take what has been returned into the hub and then certainly in the browser and write that to this series of snapshot, which gives you this nice characteristic that you can actually go back and forth on the snapshot history and see how this has evolved, assuming that this was rescheduled 3 or 4 times. You can actually have a button here and see what's going on. Now, I haven't mentioned anything about like any more sophisticated data source than like APIs like Stripe and Google Calendar. But the truth is that a lot of what we talk about in Cardstack about cryptocurrency or about blockchain, it fits really nicely with this model. Because when I want to pay someone in a cryptocurrency, that requires me to have a plugin, a MetaMask plugin, and that gets the data. And if I share that link and the other person doesn't have my wallet, my address, that information kind of disappears because the linkage, the over the wire, the access to the data source doesn't exist. It's done. It's severed. So by using the same snapshot mechanism we can use for Web API, for Web3 API, for crypto API, for blockchain-based API, we can create the same resiliency to a much newer, much more advanced and much more cutting-edge technology and give that safety and dependability. And I think that's what's lacking right now in the user experience of a blockchain-based application, is that it's really hard to get it to work for one person. Imagine if you want to invite and build this network effects. I have no idea. But imagine you say, hey, there's a shadow of this thing. If you can connect it to your wallet, I will pay you a commission or something like that. Then there's incentive to say, hey, this application works. There's a hidden treasure here. If I unpack this paid by ETH bonus system or something like that. And then once I connect it back over the wire, I can get to have another button show up in my template as I redeem your rewards or something like that. And that's the idea of using snapshots to make it happen. But one final thing I want to talk about is that snapshots and all these kind of encapsulation of data and code really is to go back to our first slide to do something relatively simple. Is that we want to create this idea that cards are completely mobile. So this ticket card, which contains its own template, its own look and feel, the goth, death metal stuff, the fields, the linkages to Google Calendar and payment and maybe Ethereum payment, the snapshot data, and the link of it. This is all just one JSON file. This is just one data structure, much like everything in your financial model is just one XLS file. That one thing is the code, it is the data, it is your value, it is existing as something in your library. If you want to say, I want to submit this, I want to share this, I want to gift it. In this case, you want to gift this. I want a ticket that I bought and I put in my home site, which is running Cardstack, and I want to push it to a place that is a local NGO, a nonprofit that wants to give kids, underprivileged kids, access to this amazing concert. You can then just say, hey, here's my ticket. I'm going to send it to you through a workflow system or just by copying the URL and pasting it in. And that URL, unlike a YouTube video, is actually pulling that information, including the ticket and payment and the transfer and maybe even blockchain records of who owns the ticket, and giving it to this new shared workspace. All we're doing is not installing app or uninstalling them or making sure versions are compatible and is it the same WordPress? Do you have an Airtable account? None of that matters anymore. Is your Airtable aligned up with my same field? Of course not, because the schema and the data are separate and different between each tenant in a multi-tenant system. Cardstack completely encapsulated so that you don't have to worry about tenancy anymore. Every workspace, every library, every site, every network, every registry, every consortium, it's just a folder that contains these cards. A card contains its own data, and if you were a composer, the card provide API and service to each other. And Cardstack framework, right, does all the hard work. So all the thing we talk about, all the layers of architecture and all the tools and APIs we build is really for creating the illusion that cards is a physical thing you can exchange with people you care about, and when you exchange it, it goes there, and all the things necessary to render it, to link it, to see it, to reliably render it, even if you don't have the permission, exists within this promise that is provided by the Cardstack. So as we kind of embark on the upgrade of this framework, we acknowledge that we have a lot of current open source projects that are on the first version of Schema, which as some of you have seen some of the talks about how we structured it. There's usually a Git repository that has the definition of the file, and then another one which is appended with -data, which has the data such as content for articles and images for Cardboard, cryptocurrency addresses for Cardfolio, Tally, an application we're launching in August, would have our concept of prepaid card accounts and service provider and billing relationship. The blockchain registry uses Schema 1.0 for the types of music recording, object, album, artist, release schedule, and do that. And we are also making a much more simple Card SDK project template for new developers learning about Cardstack. You can go ahead and see how Card Schema work and get the idea of the encapsulation that exists. But they are two separate kind of repository, two separate pieces. Going forward, as we continue working on Card Schema V2 and then releasing inside using this, is that we see a lot of use cases that requires multiple parties work together exchanging data. So if someone say, hey, here's a new license request that if you fill out, you'll be able to get this blockchain license of my song or my movie. Well, that requires us to encode the form to apply for the license, the legal language that needs to point to, the version history as we negotiate the terms, the payments, which can be done cryptocurrency or traditional way or maybe in kind. All that type of stuff requires us to use the Card V2 encapsulation of app and state and link to create this kind of idea. And we also see a world where instead of having Cardboard being your blog, you have a multi-hub, a federated network, and then they can exchange articles and syndicate between those communities. So that also require us to say, oh, someone creating this new article type that includes this card that is some VR or some data flow diagram-based visualization. Now that card has its own template, its own logic. Now can install it. Whatever hub except a new card is actually bringing in those schema, bringing those dependencies, again, with Card Catalog providing that protection, almost like acting as a registry and using some additional cryptographic and other type of moderation technique to make sure that catalog that you can depend on, that you can share, and you can move across card boundaries, much like Chrome plugins that you can install in your browser are safe. That's what we call multi-Git repository, which the catalog itself is a Git repository containing cards submitted, version control by the community and by sellers of premium ticket templates. And then card flow is a way we move it together, and card space is how you accumulate and build your own personal library. So these are the things that we have been talking about doing, and the basic structure of a card is not going to change, but the way we encode it, the way we allow these cards to be stitched together through Schema V2 allow us to really accomplish that type of really flexible multi-party workflow that will be the foundation of a decentralized way of working, decentralized way of sharing information and sharing data, and more importantly, conducting business transaction that gets you paid and gets economic value created. So future product from the Cardstack project will use the Cardstack Schema V2, and certainly a lot more documentation will come. The V1 and V2 will coexist for a significant period. But if you need that kind of multi-party workflow, I invite you to kind of follow our work on that. And finally, one really important design goal for Card Schema V2, even though V1 supports some sort of like editing of things using, if you define your schema, we give you an editing tool, what we call a right edge, that shows you all the fields that's inside that particular schema and allows you to edit it. Even if you don't provide your own edit template, you can just click on something on the view template and we'll give you a field editor for that. But going forward, we actually want to be able to let people add a field. Like if you downloaded a article template and it's missing one field that allows you to make a corporate blog or something like that, you want to be able to go and say, let me add one field. And because the definition of the card, the article card, or your derivation or your adoption of that card is just a JSON file, it makes it a lot easier for us to create user interface, allow people to create schema. This is not different than I can add a column in Excel or add a new field in Airtable. Those type of user interface, what we call four edges, right? The Cardstack environment provide that power user tools for you to say, hey, I'm just not looking at a website. Let me zoom out a little bit and see what kind of tool palette I want to actually change how this looks. Maybe the layout, maybe the template, maybe the structure, maybe add a new field, maybe accept cryptocurrency payment or don't accept cryptocurrency payment. These are all configurable, and some of them actually will change the schema, not just the data. And to the degree that it makes sense, we want web developer who knows HTML and CSS and a little bit of JavaScript. They go and say, hey, I want to make this ticket or this event or this invoice or this presentation looks a little better. Let me go into a little coding panel like what you see in CodePen and start making modification to markup and have the card just reflect your latest change. And that's the type of foundation that we've been built towards. One of the major projects that enabled that is actually a project called Embroider. Ed Falk, our lead developer, and working with many in the Ember community as well as on our team, has been building a new build system that leverages Webpack and connects to the Ember ecosystem, which is what we use a lot of our framework foundations is on top of the Ember stack. To allow much more dynamic loading of new components. And that new components could be new controls for you to edit fields if you need a fancy date range editor. But the entire card itself, this invoice card or this podcast card, is actually just another module. In JavaScript term, every single card and every single field inside every single card is an NPM module. And we can install that in real time as the user encounter them. Oh, I receive a new licensing request. And that's when your application loads or auto imports the necessary code to render the template to give you a drop control or select how many impressions you want to get your limit and therefore changing your licensing price. All of that formula and those things are part of the coding things. And that's the exciting thing about the Cardstack framework. So creating more with less, providing the tooling allow much more people to create and iterate and share in this card-based economy to break out of these app that we both love and hate on our phone, where only people who are iOS developer and Android developer can craft these perfect nuggets of scrumptiousness. But in fact, they're a little prison of your data, and a little prison that doesn't want to interop with each other. The card vision, which is based on the World Wide Web vision, that's why we call ourselves the application stack for Web 3.0. We want to break that out, recombine these pieces that is now locked into little apps in your branded icon in your home screen and let it be flow a lot more fluidly, so it's in your workflow within your space, shared in a catalog, and using open source tool like Git and blockchain to share that across different people. So that's what we want to cover today. I know this is quite technical and is really intended for a developer audience, but a lot of the spirit and understanding and the principle of what we discussed on the card schema is very much what we have been, at least personally, I've been pushing towards to try to rethink what a document-driven, what a unit of exchange-driven economy on the web is going to look like. And I believe this is going to be a vision that we get closer and closer to as we move to 1.0, which gave us the schema 1.0, most of the plumbing for indexing and display and rendering and login and log out and search to go and make it one level better, so that new encapsulation provides an ability to actually make a federated, decentralized, if you're using a blockchain underneath your federation as a membership, that really makes a decentralized web a reality. Not just in theory, but in the same scrumptious, amazing user interface quality you expect from an app that you subscribe to today. So that's Cardstack schema and a Card schema 2.0 design, and we'll give you guys more update as we have code samples and guides for people who want to experiment with the cutting edge of what a card is. Thank you so much. We'll talk soon.